Here are some more examples of elimination. Notice looking at the two equations, the x's are lined up and the y's are lined up on the left, the equals and the numbers are on the right. However, if we tried to add these right now, the x's, 2x and 3x, makes 5. That does not eliminate. And the y's, a y and minus 2y, also does not eliminate. We need the x's or the y's to be the same number but opposite, so that the positive 2 and negative 2 would cancel out. What we're going to do, and I just gave a hint, is for that y variable, if the bottom equation has that minus 2y, we want the top equation to be a positive 2y. What we can do is we can take the entire top equation and multiply everything by 2 so that our y will say 2y. So our answer, our next step will say we now have 4x because it got multiplied by 2. We now have 2y because it got multiplied by 2. And instead of 10, we now have 20. The second equation stays the exact same as it was, so I'll rewrite it. 3x minus 2y equals 1. Now, if I try to add the two equations together, the y's should eliminate. 4x plus 3x is 7x. Positive 2y and negative 2y eliminates the y's. And then 20 plus 1 is 21. Last step to get the x by itself, divide by 7, and we have x equals 3. This is not my final answer. I still need to go back, plug it in, and find the y. I'll use the top equation. You don't have to. You could use the bottom equation and show my work. We had 2x, put in our answer of 3, plus y equals 10. 2 times 3 is 6 plus y equals 10. You might know in your head the answer is 4, but we can minus 6 on both sides to get the y by itself. Then we get y equals 4. We are finished with elimination. It's the same strategy you've seen previously, only difference is that very first step we had to pick an original multiplier in order to get those y's to both be a 2y and cancel out. I should still check my answer, so if we take the bottom equation and check our answer, 3x, our answer was 3, minus 2y, our answer was 4 for y, equals 1. 3 times 3, 9. 2 times 4, 8. And 9 minus 8 is 1, so our answer is good. Let's look at a word problem. On Tuesday, the cafeteria sold pizza slices and burritos. The number of pizza slices sold was 20 less than twice the number of burritos. So we need twice the number of burritos and 20 less than that. So I'll start kind of writing this equation that if I do twice the number of burritos and 20 less than that, so 2b, twice the burritos, and 20 less, so minus 20. That will give us the number of pizza slices. And I'll write myself a key for part A. It says write two equations and with two variables to represent the information. Be sure to define your variables. So I'll just say that B was the number of burritos and P was the number of pizza slices. All right. If I go back to rereading the story, it's probably going to give us information for another equation. Pizza sold for $2.50 a slice and burritos for $3 each. Cafeteria collected a total of $3.58. So I know if I take my money per pizza and, meaning plus, my money per burrito, the total should equal $3.58. My equation will look like $3.50 for a pizza plus, I wrote that wrong, it is $2.50 for a pizza. Excuse my mistake. $2.50 for a pizza plus $3 for a burrito. And that should equal a total of $358. Notice the formatting of the equations. One equation has pizza and burritos both on the left and the number on the right. The other equation has the pizza separated from the burritos with the equal sign. This is not in the proper alignment for elimination. Because of the p equals, this is a better candidate for substitution method. But for the sake of practice, I'm going to set this up for substitution. All I'm going to do is get the pizza and burritos both on the left by minusing 2b on both sides of my equation. Minus 2b, minus 2b. So now that blue one says pizza minus 2b is equal to negative 20. Don't worry if you can't do this step. I won't ask you to do this again. Now our equations are set up for elimination. I have pizza both on the left, the 250p for one equation and regular p for the second. And then I have burritos, 3b for the top equation, and minus 2b for the second equation. The way these are set up, nothing right now will eliminate. But I noticed the 2.5p and p. I can get this bottom equation to eliminate the p's if I multiply, instead of by positive 2.50, the opposite, negative 2.50. And I'm going to multiply all the parts of my equation by that. So let's rewrite. First equation stays the same. 250 per pizza slice plus $3 per burrito was $358. Second equation with that times 250 multiply negative 250 multiplier, we have negative 250p. And then here we have a negative 250 multiplied by a minus 2b, and that's actually going to give us a positive 5b equals, and negative 20 times negative 250, again turns a positive. Using a calculator, negative 2.50 times 20, negative 20 is 50. Now I am set up to eliminate my equation, so I will add the two things together. Negative 250 and positive 250p eliminate. Positive 3b and 5b is positive 8b. And 358 plus another 50 is 408. To get the b by itself, I need to divide by 8. And we get b equals 51. So now we know that for this word problem, they sold 51 burritos. Now that we know that we have 51 burritos, we can use these burritos. Oh, that's an eraser. We can use these 51 burritos to plug in and calculate how much pizza was sold. So I'll take 51 burritos, calculate number of burritos here. So P equals 2b, we're going to replace b with 51 burritos, minus 20. 2 times 51 is 102, minus 20 would be 82 slices of pizza. And we could check our answer by checking it into the equation about price. We knew that it was $2.50 per pizza slice, 82 slices, plus, I ran out of space, $3 per burrito, 51 burritos, and if we calculate, multiply, and add those, it does equal $358. Before I leave you to finish the assignment, let's take a look at the next problems. If these were my two equations to eliminate, 3 and 7 for x does not eliminate if I add them together. 4y and minus 2y also does not eliminate. I need the same number, positive and negative. 3 3 and 7 don't have that common multiple number. I can't multiply 3 by something to get to 7. But for the y's, I can multiply -2 by something to get to 4. And that way I could have a positive 4y in the top equation eliminate with a negative 4y on the bottom equation. So if we set this up, this bottom equation needs to get multiplied by what number, so that the y's would now say -4. We need to multiply by 2. I'll let you rewrite the first equation, multiply everything in the second equation by 2 and rewrite it, and then try to add the equations together to finish the elimination process.